so here's a kinematic problem that involves paying attention to sign conventions. So we got a jet plane. Here's my jet plane. This guy comes landing with a velocity. So V initial is positive 100 meter per second. Positive meaning what? Forward to the right. So our sign convention's like this. To the right is plus, to the left is minus. Okay, and the airplane can accelerate at a maximum rate of -5. So that's our acceleration. So why -5 meter per second squared? What type of acceleration is that?
Deceleration.
A deceleration. You know, typically negative accelerations are decelerations, but not always. When would a negative acceleration be an acceleration? When would that happen? Yeah, or when your velocity is what? Also negative. You know, if this airplane were moving to the left, which is negative, and had a negative acceleration, then it'd be going faster, faster, faster. So here it's a deceleration because the acceleration is opposite the velocity. All right, so what are the questions here? From the instant it touches the runway, what is the minimum time needed before it comes to rest? Oh, let me put in the, here we're going to add image here. We're going to put the airplane final right here. So there's this dude. Shrink him down. Oops. Shrink this guy down. Move him over. Okay, so here he is final when he stops, right? So over here we got V final. What's his V final? Right here where it says comes to rest. V final is 0. Okay? All right. What is the minimum time? So we're solving for T here, the time required for the airplane to stop. So you got to look at your list of motion equations. With this information, the equation that's going to solve part A is V final equals V initial plus AT. And the only missing variable here is what? T. Now, I know that you guys, students love plugging numbers in as quick as possible. It's like the quicker the better. I encourage you to do the algebra first. It really is the way to go. In my AP class, it's required because that's what they want on the AP exam. But, you know, in here I won't be hardcore about that. You really should do the algebra first. So what is V final? 0, so we cross that out. So we're basically left with negative V initial over A. So that's going to be negative 100 meter per second divided by the acceleration, which is also negative. Right? So the negatives cancel, and we get T equals 20 seconds. That would be the time required for the airplane to stop. Okay, now part B wants us to figure out, could this airplane land on a small tropic island airport where the runway is 0.8 kilometers long? Ooh, tricky here. What do we have to do to this 0.8 kilometers? That's 800 meters. So what are we solving for here? X. We're solving for the displacement from here over to here. What's the stopping distance? Okay, so the equation I would use here, a real nice one, I would just, there's multiple equations. I would go X equals 1/2 VF plus V initial times T. That's the second equation. What is V final? 0. So we're left with this. We're left with X equals 1/2 V initial times T. So now we plug numbers in. So V initial was 100. T is 20. We just calculated that. So this is going to be 1,000 meters. Could this airplane land on this island? No. Because what's the stopping distance required? 1,000. And then the island, how long is the runway on the island? 800. So that would not be good. Hey, actually, there's a runway on Catalina. I haven't heard of it happening recently, but it's a pretty dangerous airport. Did I say airplane? There's an airport. There's an airport on Catalina Island, and the runway is not the longest. And also, I think there's like a buckle to it. It's like kind of bent, so like it kind of tricks pilots. Yeah.
It was on the Discovery Channel's most like dangerous airports in the world or something, I think.
Yeah, it's short and it's deceiving. So, anyway,